But for the ones who are not familiar with the software, I just wanted to show you a quick video for the introduction. Let's start.
Bridge Steel is the complete package for the design, analysis, and rating of steel bridges. And by complete, we mean the software addresses all fundamental areas of steel bridge design, from modeling to code check compliance. So let's take a look at just a few of the benefits of using Leap Bridge Steel. Modeling, analyzing, and designing steel bridges has never been easier or quicker. Using Leap Bridge Steel, existing civil data like alignments, profiles, and DTM data can be imported from Geopack, InRoads, or MX Road to start a new bridge model or models, resulting in a distinct productivity advantage from the start. Building on imported civil data, a bridge can be quickly and easily defined in terms of slabs, girders, cross frames, piers, and/or abutments, using Leap Bridge Steel's parametric modeling interface. Changes made to the model are instantly reflected geometrically and in load cases applied to the model. These productivity advances result in quicker turnaround, shortened project schedules, and the ability to review multiple design alternatives. Using the completed bridge model, dead and live load analysis is quickly performed, and the results are viewable graphically and in report format. Leap Bridge Steel transparently uses the STAAD Pro engine for all structural analysis. STAAD models created by Leap Bridge Steel can be used for more advanced analysis directly in STAAD Pro. Performing design calculations that are compliant with the AASHTO Bridge Design Specification is extremely important to the bridge designer. Leap Bridge Steel is compliant with the 6th and 7th editions of the AASHTO LRFD Bridge Design Specification. High-quality reports are the end product of this phase of the design process, which shows all pertinent articles and equations that are checked by the system, providing the engineer confidence that all calculations are compliant and removing the black box effect. From start to finish, Leap Bridge Steel provides a data-rich environment. The bridge model, plus analysis and design data, can be used for many extended purposes that increase productivity. This includes preliminary and final drawing preparation, public hearing presentations, and construction staging.
Okay. I hope everybody is more familiar with the product now. Okay, now let's take a look at the analysis and design capabilities of the Leap Bridge Steel a little bit closer. So with Leap Bridge Steel, you can model straight and curved eye girders as well as straight and curved top girders. We are offering 3 different analysis types: line girder, grillage, and 3D finite element analysis. So depending on the complexity of the model, depending on the complexity of the structure, and depending on the accuracy level you are seeking, you can choose one of these 3 different analysis types, and all of them are available. In addition to that, for both eye girders and top girders, we are offering LRFD design check. So you can see which articles are passing the AASHTO checks or which are not passing. You need to modify the plate sizes. In addition to this, we are also offering design optimization for eye girders, and it will be offered for top girders in 2018. Design optimization is different than design check. So in design optimization, all of the iterations that you need to carry out for the plate sizes is going to be done by Leap Bridge Steel internally. And then it will give you the safe and the most economical plate size at the end. Last but not the latest, the load rating capabilities are also offered for eye girders and top girders. As you know, the new bridge designs typically in most of the states are submitted with the initial load rating. So this is important too. Okay, now what's coming in liquid steel in the latest version, which is called V17 Update 1, which was actually released only a few days ago, November 6th. If you look at the list of enhancements, we upgraded the 32-bit liquid steel to a 64-bit liquid steel. Its 64-bit liquid steel is going to be a high performer, and also there will be no issues if you have big models or complex models. You can run it with no issues. We also made some enhancements to the top girders, such as top girder load rating and also automatic plate generation. Automatic plate generation is a little bit different than the design optimization, and we will get into the details later. We also introduced the centrifugal force effect in our analysis. Another enhancement was superimposed deadload distribution to girders. We made some enhancements to the load rating reports, and we introduced two definitions, wearing surface and travel way definitions, which will make life easier for the users. So let's start and go one by one. So top girder automatic plate generation. This is, as I said, this is different than design optimization. Automatic plate generation is only giving you a good starting point when you are sizing your plates for the eye girders or for the top girders. And it's based on the common practices in industry and based on the cross-section proportion limits, according to AASHTO. As I said, this automatic plate generation algorithm does not depend on any loads or analysis results on the bridge, but only geometric input from the user. So let's take a look at this member definition window and how we can use the automatic plate generation. If you go to the generate place, you have the options to generate the place for selected member or all of the members. So if you select the selected member, it will give you a warning saying that the existing member elements will be reset and asking if you want to continue. If you hit OK, it will offer you initial plate properties for flanges, thickness, width, or web thickness and depth. As I said, this is again depending on the cross-section proportion limits for AASHTO. If you hit OK, that means you accept what's offered, or if you don't want to go with that plate size, you can even increase it and modify it. Now all of the plates on the all girders are created now automatically. So this is a good starting point. You can go ahead and run analysis and then design check and then see if this is sufficient or if you need to make adjustments. Okay, second one, this is one of the most important features we added to liquid steel, centrifugal force effect. As you know, centrifugal force effect is applicable to the bridges curved in alignment, in horizontal alignment. And it's actually composed of two different forces. One is centrifugal force itself, the horizontal load applied to the truck with a certain height, creating a force couple in the wheels, and one wheel is pretty much lifting up, the other one is pushing down. And also, the other effect that you are allowed to use, according to AASHTO, is the super elevation effect. Super elevation effect is working on, in contrary to centrifugal force, by pushing the inside wheel down and pulling the outside wheel up. How we are defining this in the liquid steel, in the load step, for each vehicle you can define the design speed of that vehicle and check if it's used in fatigue load cases or not. It changes one variable in the centrifugal force equation. Depending on these input in the reports, we are reporting separate effects for centrifugal force and super elevation effects, so you can see everything clearly and in a detailed way. And for each type of load case, for example, negative moment, maximum negative moment, or maximum positive moment, or shear, you can see the effect of centrifugal force and super elevation separately. The next one is the superimposed deadload distribution to girders. So what's superimposed deadload? Deadload applied on the deck after hardens. So this can be parapets, this can be median, sidewalk, railing, anything on top of the deck. So as you know, different DOTs, different agencies have different preferences of how to distribute these loads to the certain girders. Some DOT says 40% to the exterior girder and then 20 to the rest if there are 4 girders, or any other configuration. So under the deadloads, you can go to SDL distribution and distribute the each appurtenance load however you want with a different distribution percentages. Also, we made some enhancements in the load rating report. Previously, it was a simpler report, not providing too much parameters how the rating factor is calculated, but now we extended it, and everything is more detailed. And you see, for example, DC1 load, DC2 DW, all of the different loads separately, and it's easier to check if the rating factor is correct and the rating tonnage you're calculating is correct. In addition to this, we added a summary report that you can see the controlling rating. The other thing is the varying surface definition. Previously, user need to calculate the varying surface load for each girder himself and then apply it on the girders manually. Now we are introducing this varying surface definition in which you can define the limits of the varying surface in the transverse direction of the bridge. So you select the left reference and then right reference. These references could be edge of deck, alignment, or any appurtenances on the deck. And you can, if you want, you can enter some offset from these references. And with unit weight and with thickness, the total weight of the varying surface is calculated. In addition to this, under the loads window, you see that varying surface load is automatically created for you. And if you double click on this, you see the magnitude of the load calculated and then the range of it, the applied range. Travelway definition, this is another important feature we added. So pretty much we are defining a travelway limits. Travelway limits are pretty much for the lanes. We are defining where the lanes should be located in between. Lanes cannot be outside the travelway limits. So again, it's similar to varying surface definition. You have a left reference and right reference, and these references could be, again, the edge of deck, alignment, or any appurtenances on the deck, and then you can enter offsets if you like, and your trucks will be run in between these limits. So, in addition to this, since you already defined the varying surface previously, you can synchronize the varying surface definition with the travelway definition. You know, most of the times they are the same. If it's from sidewalk to sidewalk or parapet to parapet, you can simply click on this sync with varying surface definition, and then the same definition will be copied to travelway. So with this feature, if you don't want to run your truck over the parapets, then this will prevent over-conservative exterior girder design and analysis results. Now I want to leave the stage to Alex Mebridge. He will show us how to produce some deliverables and drawings with liquid steel.
Thank you, Burak. Well, good afternoon, guys. Here, after all the design is performed, yes, we need to submit reports, we need to submit deliverables, right? So first, all the output, all the input that you see, everything is graphical. That's what we intended to do, right? But then how you review your work, or how somebody else can check what you have entered on the screen. Well, very simple. We give you a report called input data. So it's almost a step-by-step report on what you have entered to produce your bridge. So you don't need to actually go into the software and click on every option to see the parameters that you enter were the appropriate ones. No, you just run the input data report, and it will give you a PDF document, a Word document. You can email that too, so you or somebody else can check what you have created on the screen. Right? It could be very detailed, as I said, step by step, from the alignment you use all the way to the size of the plates, right? So it's a very extensive, very comprehensive report on what you have entered. So you can really check your work like that. Now, what about geometry? Yes, we can read geometry, alignments, profiles, cross-sections, super elevations. So then we can create accurate geometric reports, like deck elevations, right? So from where to where, on what conditions? Well, it's just a matter of selecting what locations you want to consider for not only the deck elevations, geometry ones, but also for discrete reports, okay? And specify what portions of the deck you want to map, like from support 1 to support 6, and then where you want to generate the elevations, at the edge of the deck, at the center line, along every beam path or girder path that you have defined, and how many points you want to generate, every 10th along the beam maybe, right? And give you a report, deck elevations, discrete elevations, and not only by station and offset, that mostly we provide something like that, but also an XYZ report. So we can see every coordinate, especially for grading machines, that they need that kind of output. And as I said, it could be saved as an ASCII file, an Excel spreadsheet, or just a simple PDF document. So that's another report. But then how we get discrete elevations? Well, you need to calculate camber diagrams, right? On what conditions? Well, again, after the design is performed, you will select the options in reports and say, well, I want to study these conditions, loading conditions for my camber diagram, and just review it. Now, as you see the button, Save DGN, yes, that graphic is actually a microstation graphic, and you can save this in a separate DGN file. More reports. So now what else can we do? The entire model, as you can see here, can also be saved as a DGN file. So we provide a zip file in the background, and it just saves your model there. Remember, this is not a sketch. This is not something that we just built up in the air. We're using the real alignment, the real profile of the roadway. So ideally, and if you did it right, well, your bridge should be filling that gap between the roadways, right? So that is the model. And you can save it. Or we also provide a microstation screen. Well, actually, this is a microstation viewer that you see. We can just generate drawings for that. So on these drawings, you can select it, and you can create plan views, framing plans, and bridge cross sections. You will create separate DGN files for each one that you select, and you can also map a specific level symbology to each one of the elements that you have in your bridge. So you configure that, well, your bridge will come in your DGN file with the proper level symbology according to your standards. So as I said, you don't need MicroStation or any Bentley application apart from LibSteel to run these reports. Okay, it will just save it, it will create internally the DGN file for you. And as I said, you can open this separate. For example, I'm going to open it here in MicroStation Connect Edition, or could be MicroStation BLI, as it all depends on what you have in your computers. As I said, it's just 3D MicroStation file for that. So I can just go right click and open these drawings there. And so I have many versions here. I have OpenBridge Modeler, OpenRoads Designer. Well, I will open just with plain and simple MicroStation. Let it open. What is going to come, let's do a feed view on that. right? That will be my typical section, plain and simple. Okay, and this is not a sketch, it's not an image, it's actually lines. It's a vector file that you can modify, put it into your sheets, and compose your drawings. Right? Your framing plan, for example, as well. And again, here I'm not opening this in MicroStation. I'm taking advantage of the MicroStation viewer that is inside Leap Steel to visualize what I'm generating. So if I see something wrong, or maybe I see the need to optimize some of the sections, don't worry about it. Just go back to your design, perform it again, the analysis, the code checks, and then just ask the software to regenerate these drawings. As I said, the same typical section that I open in MicroStation, I can visualize it here. You know? And then, as I said, I can also save the entire 3D model, the DGN file of the bridge, just by clicking Save DGN, right? I'm overwriting this, that's fine. Then just open it with MicroStation, maybe again. And then I will have the 3D model of the bridge. So not only can I create drawings or sections, if you will, framing plans, plan view, and typicals, but as well get a 3D model of my bridge. So let's do a fit view. And as I said, this is an accurate 3D model because we're using the coordinates that are coming from the alignment and profile of the bridge. Okay, and it's a complete picture, if you will, of the bridge, because not only has the beams, it has the cross frames, the substructure. So there you have it. You have an entire 3D model of your design for a steel bridge, either eye girders in this case, or could be tops.
All right, great. Thank you very much, Alex. It was a very good presentation. So before we take questions, we have a poll. If you could vote it. While we're waiting for the poll, Alex, do you want to give us a quick summary of what you are going to present on December 14th about the OpenBridge modeler and the BIM workflow?
Sure. Well, on BIM, you know, this is a term that, as you said before, it becomes very popular now, and not as much popular. I would say that it's almost maybe a mandate from the industry in general that we're going 3D, but 3D not just on the sense of creating a 3D model for visualization, but a 3D model that we can use on design, on visualization, of course, but as well all the way to construction and operations and maintenance. So we need to create a real 3D model that has intelligent information inside. And the only one that can do that in Bentley is OpenBridge Modeler for a bridge, of course. And then we're going to present the challenges that you will front when you are trying to implement this BIM workflow. I mean, BIM is not a software solution, it's actually a workflow that you need to implement within your organization. We're going to recommend you more or less the steps that we think are necessary to accomplish a successful BIM project.
Great, thank you, Alex, and thank you for the answers. I think it's time to close the votes. Thank you. Okay, now we are taking questions. What is the latest version of Leap Steel? Is it available for download? Yes, it is available for download since November 6th, and the number is, I'm going to put it in the chat window. $17010038 is the latest one, which is in, you'll see that in the fulfillment center that it's a x64, so it's a 64-bit application. Okay, Adam has a question for you, Alex.
Yes.
Are these MicroStation modeling features going to be available in Leap Bridge Concrete soon?
They are available already. if you go into the drawings tab into LibBridge Concrete, yes, you can generate plans, you can generate typical sections, substructure sheets. So yes, there is I would say, a lot of features on drawing production or drawing sketches in LibBridge Concrete now.
Thank you, Alex. I see that a few questions are on the way. Okay, Gary from Oregon DOT. Does Bentley have a white paper showing benefits of 3D modeling of bridges? Any help in changing existing culture would be appreciated. Okay.
Yes, we have that. It's actually, I authored that paper, and it's called the advantage of 3D modeling. Yes, there is a paper, and actually, let me recommend you, there is a book now on the Bentley store. They just announced it yesterday. There is a book about BIM. It's called Plain BIM, published by Bentley, in which you can see the experience that Bentley had. Actually, in this case, it was in a project in the UK. So there is also a book, and you can find it in Amazon. And this white paper, you can download it if you go into our Bentley Bridge page, and there is a link to download this white paper. And other papers published as well for Bentley colleagues here.
All right, great. I see another question. Do you also have 64-bit version of Lib Concrete? No, unfortunately, no, not right now, but we are working on it. However, we upgraded the substructure module to 64-bit already. So LibBridge Concrete superstructure module is not 64-bit, but the substructure module is 64-bit right now. Steve has a question, does Lib still do the design of the connections? The answer to this is no, not yet. It's in our plans for 2018. It's a very good question. We are doing field splices, but not, for example, connections for the cross frames, etc. Those are going to be in the software in 2018. But yes, we are doing field splices. Okay. Adam, LibBridge Concrete version 17.1 seems to have an issue dealing with superstructure load paired to substructure when a SKU is introduced. Does still address this issue? Adam, I'm going to forward this question to product manager of LibBridge Concrete, but for LibBridge Steel, we haven't experienced such an issue so far. And for LibBridge Concrete, we released a new version a few days ago as well. I don't know if you have tried that one. Okay. Yeah, if you could download it and take a look at that one, it might have been already resolved, but I'm going to definitely forward your question to PM for the LibBridge Concrete.
Okay, let's take another question.
Okay. I think that's all we are going to take.
Maybe one last question. Okay. Somebody's typing. And then here you see the links of the information that regarding the white papers. And as Burak mentioned, yes, we have released a couple of days ago the latest version of LibBridge Steel and LibBridge Concrete. So they are already in you select server downloads. So it's just a matter of accessing the Bentley page and downloading the latest version of both products.
Okay, there's a good question from Mohammed. He's asking if LibBridge Steel analyze more than 20 degrees skew. The answer to that is yes. You can introduce any skew degrees for the support as you want. You can select grillage analysis or FEM analysis for the any type of bridge skew. Okay. I guess there's one more question.
Keep coming.
It's great. Great.
know. And just to mention, on that DGN files that we generate for the views, it's just standard 3D files, but then we provide a seed file, and of course, you can also put on the software your own seed files for your organization and map the level symbology with a DGN lib to the specific structural elements that are coming from Bridge steel. So it will come up to the proper level symbology that pertains to your organization. There is a question that says, can you model a pin and hanger? We will need more clarification into that. Maybe we're going to take it offline and answer after that.
Right. Can you explain a little bit more, Adam, what you mean pin and hanger?
We can take it offline afterwards and post it. All these questions and even the recording is going to be available on our Learn server after we finish this, as this presentation is being recorded as well.
And you can also email any kind of questions related to or unrelated to Bridge steel to my email address you see on the screen, brockvoyager@bentley.com. You're always welcome to ask any questions. Okay, I think we are concluding our meeting here. Thank you very much for joining, and we would like to see you on December 14th for the next SIG meeting. Thanks a lot.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.